Kind of nice, actually. So a couple of things I want to make you aware of here. We're used to, when we were doing this before, and I'm going to add one thing here at the top. We used to have this thing called standard form. That's what we've been working with for the last 3 days. And we've had to go through, and this is the form it was in, and to find the vertex value, at least for x, we had to do this fancy formula. And some of you are like, yeah, I wasn't too giddy about that. That wasn't a big fun time. Now what we're going to do is we're going to start dealing with vertex form. We are not going to deal with intercept form today, because vertex form actually takes the vertex work out of things, hence vertex form. So let me show you how this is going to work. And at first you're going to look at it and you're going to go, wait a minute, what? You're like, this doesn't look easier. This looks like it might be harder. Now you're getting into parentheses and all this other fancy business. But here's the cool thing about it. With vertex form, whatever value is in the parentheses with x and whatever value is on the end actually tells me what the whole vertex is. I don't have to plug it into a formula anymore. So here's how this is going to work. And we'll get an example down here and we'll do some of the homework ones together. But I want you to see how this kind of works mathematically. So what we're going to do, like we'd mentioned up above, I'm going to skip this blank for right now. Okay, the vertex is HK. Now here's the part that's tricky. H is the opposite of what is in the parentheses. And I'll explain that a little bit better here in a minute. I'm actually going to put a couple of examples off down the left side of this, because that's the one thing that people tend to get messed up with on graphing in vertex form. For instance, they'll see something like, and I'll just, like I said, I'm going to draw a couple of them over here just so you can see how this works. They'll get something like this. Y equals the quantity x plus 3 squared minus 4. And they look at that and they go, okay. And when I tell them, well, the vertex for this is -3, -4. And they say, okay, I see where the -4 comes from. That's right here. But why isn't this +3? And that's what I'm talking about with this whole opposite thing. The form says x minus h. But what we're really saying that is it's x take the opposite of h. The opposite of +3 is -3, so that would be my vertex. Just in the same way, if I had something that looks like this, okay, x minus 2 quantity squared plus 5, my vertex would be at 2, 5. Because I take the opposite of what I see in the parentheses. So I see -2, I'm going to write down +2. But the number outside stays exactly the way that it is. But just like before, because there are some things that are still similar to before, the graph still opens up if a is greater than 0, okay, if it's positive, and it still goes down if a is less than 0 or negative. So everything's going to be the same as it was before, except now I'm being given the vertex. And then I could make my chart if I wanted to, or use the calculator to help me. So let me move this up a little bit, because we're actually going to get a full-blown worked out example to play with here. So I start to look like, check this out. And some of the things that they're talking about doing here, I'm not going to do. I'm not going to worry about talking about translating and stuff like that. We're going to plot the vertex. We're going to make a chart. So here's how we're going to do it. So for up here, okay, what's my vertex going to be? Yeah, my vertex is -1, -2. Okay, because again, whatever I see in the parentheses, It's the opposite sign of that. So I see positive 1 in the parentheses, I'm going to do negative 1. I know, it's weird. It is. So I'm going to plot that point. So negative 1, negative 2, plot my point. Now normally here, this would be the time that we'd say, okay, I'm going to make a chart. I'm going to put my vertex in the middle. And then I'm going to start getting all my other numbers in. Now again, with having the technology available of the graphing calculator, we're going to make this really easy. I want to keep adding 1 each time as I go to the right and subtracting 1 each time as I go to the left. And normally I could just plug these into the equation, but especially with the fraction, do I really want to do that? Not really. So instead, what I'm going to do, if I can squeeze it in here, is I'm going to go ahead and I'm going to type this into my y equals. Now, instead of doing, and just kind of watch, if you're doing it on your calculator, don't do this yet because I'm going to explain how this could cause me a problem. If I were to start typing in my equation like this, and I get to the end and I'm going along, and I do this, I'd have a problem. Because the calculator would think I want to do 1 divided by 2 times that, and I'm like, no, I don't want to do that. So if I'm going to use the 1/2, I need to put it in parentheses. But what's 1/2 as a decimal? 0.5. So I'm just going to use the decimal instead for my 1/2 here, because then I'm less likely to get myself in trouble. So that's my 1/2 x plus 1 squared minus 2. I still got to be careful when I type it in. But just like we've been doing the last 3 days, to do the table now, I just do second and graph, which gets me my table. And that negative 1, my x value in my vertex, is what I want in the middle of my screen. Because now notice, okay, there's the negative 2. I knew that was negative 2. But check out the values. Negative 1.5, they're the same. 0, they're the same. They're symmetrical. 2.5, they're the same. So I can fill in my chart now. Negative 3 is 0. 2 is negative 1.5. Negative 1.5. And 0. And now instead of all the complexity that they're asking for over here, I don't need to play with all of this stuff. That's kind of silly. I'm just going to steal my vertex and then do what I want. So, negative 3, 1, 2, 3, I'm at 0. And at negative 2, I'm at negative 1.5. And at 0, I'm at negative 1.5. And at 1, I'm at 0. And again, it kind of looks like a triangle when I'm there, which is good because that lets me make my parabola. And that's all I need to do. So the only difference with this stuff versus what we've been doing is, now instead of figuring out the vertex, I just steal it right from the equation. Otherwise, I type it in the calculator, I go about my business. This note sheet you'll want to keep somewhere safe because we will come back and do some intercept form stuff later next week. But for now, we're just sticking with this stuff and we're not dealing with all this other crap, we're just keeping it simple. So, we're going to take this, we're going to put this off to the side. And the worksheet that goes along with this, we're going to jump in and do the first couple here to kind of kickstart you. You like having to find the vertex better?
Yeah, it's easy.
That's better than this? What? You mean the fact that here I can just look at this and say, what's the vertex? Change the sign and keep it. Well, and there'll be more often than not, it actually ends up being in the other form than it does this. Well, that gets me my vertex instead of having to plug it in.
You can put it in a thing on the calculator and you can get the vertex.
You can figure it out that way too. That's true. That's true. So once I have my vertex, I'm going to clear this out. I'm just going to type what I see. Negative x minus 4 squared plus 3. Calculator's still going to do all my work. And again, to get my table up, I just hit second and graph. And then just make sure that my vertex number, whoops, I'm going the wrong way, is in the middle of my picture, because then I see the symmetry with 2 and 2, with -1 and -1, and with -6 and -6. Now, do I have to draw the chart? No. I mean, I'm going to here just because if somebody's watching this later, I want to be able to see what I'm up to here. So I'm going to put my vertex in the middle. And then again, I'm just going to chart it by adding 1 each time as I go to the right, subtracting 1 each time as I go to the left, and then just copying what's already there for me. Can't get much easier. Then I just plot the points. 2, -1, 3, 2, 5, 2, and 6, -1. I notice it opens down like it should because there's a negative in front. My A value is negative. And I'm rolling along. So let me get one more on here, and then we'll kind of see how we're doing. So let me get back to y equals. Okay, for number 2, what's my vertex going to be? Okay, -1, because I always just take the opposite of whatever's with x, and then keep what's on the outside. So -1, -2. Put a dot. And again, just type it in. 2x plus 1 squared minus 2. And again, second graph to get the table. But I want -1 in the middle. There we go. -1, -2, just like I thought. And again, I see the symmetry with the 0s, the 6s, and the 16s, which tells me that I'm doing it right. Now, if you want to skip the table, you know, drawing it out like we did in number 1, that's okay. I don't care. You could plot all the points you see here if you want to, except I don't think -416 is going to fit in our graph. But -3, 6 will, and -2, 0 will. And I already got the -1, -2. 0, 0 will. And so will 1, 6. And there's my symmetry. That's all you're doing on all of these. Nothing tricky. Just steal that vertex to give you a little heads up on where you're going to put your chart once you bring it up. And then just copy the points. Any questions? All right.